We're good to go. Okay, thank you guys for coming along to RemoteFX Drilldown. I thought I was going to be the last session before drinking time, but I found that there's another one right before drinking time. So I don't feel kind of so bad that I'm holding you up from drinking time. So I think we all want to go. So this is RemoteFX Drilldown. What is it and how does it work? So I'm going to spend a bit of time talking about what investments we've made to basically enable this to occur. I'm going to spend some time talking about what's actually going to be required in terms of performance, in terms of like servers, you know, the sort of servers we see RemoteFX being enabled in. We'll talk a bit about some of the work we're doing with some of those top tier OEMs and basically go over the architecture and also contrast what it is and what it is not. So what we think around RemoteFX is we think it's a bit of a game changer. We believe we'll be first to market with a GPU back-ended solution for graphics processing. Basically what occurs, the thing we spend probably the most time talking about is this vGPU support in RemoteFX. The reality is there's actually three different components of RemoteFX that we're going to talk about today. vGPU is probably the pretty shiny thing. It's the thing that you see the most. What it allows you to have is a full Windows-rich experience to a device like this. And for those of you who didn't see this in the foundational keynote on Monday, this is a thin client that an Australian company is actually producing. When we acquired Calista Technologies, who was basically producing this technology, one of their developers actually left and went to join this company. His name's Jay. For those of you who are in the Linux camp, he's one of the authors of the RDesktop protocol as well. Basically, this thin client is a Linux bootstrap thin client, starts the IDP stack, but has the RemoteFX decoder built into an ASIC on chip. This is a prototype unit. Now, the interesting thing about this device is it doesn't have really any smarts in it at all. It basically receives IDP in, it's got an IP stack, receives IDP in, it's got a decode protocol in it, takes the decode and pushes it to screen. There's no GPU in it at all. It runs with about 3 to 5 watts of power. I can't remember exactly how much, but very, very low wattage. Now, the interesting thing for me is the price point, because up till now, the thin clients you've bought from various different OEMs have generally been in the $600 to $1,000 range. So when you're kind of doing the like the value prop of do I buy a rich desktop or do I buy a thin client, 9 times out of 10 you're going to go towards a rich desktop because at least then you can use it for other things rather than just being a thin client. This one, they believe, will start to retail at around $150 US. They believe at volume, they'll get that price significantly down. So this will actually enable some very interesting use cases. Now, when I talk about RemoteFX decode protocol, that actually implies there will actually be a part of RDP. So you'll also be able to use the decode part with RDSH, session host. The vGPU part, which we'll discuss in a second, is not going to be part of SH. We'll talk about that in a second. But when we think about RemoteFX, the primary thing we're talking about really is VDI, because most of this capability is actually delivered as part of the virtualization host. So the vGPU, the host-side rendering, intelligent screen capture, and hardware-based encode, all server-side functions, all out of RDVH. The USB device redirection is also RDVH, VDI only, not session host. Hardware-based decode is stuff like this. But there is some stuff that will absolutely work with RDSH. So what we'll talk about is the differences that you get with RDSH as opposed with RDVH. And I'll show you some demos, and I'll show you what RDSH offers you today already, right now, with current thin client technology. So the three main improvements in RemoteFX. There's an improved encode-decode pipeline. There's basically this thing called the vGPU, or 3D GPU host-side rendering, and there's USB redirection. RDVH supports options 2 and... Well, actually, RDVH supports all three. RDSH only supports the encode-decode pipeline. So basically what happens within the RDP stack is there is a function of that stack which basically takes bitmaps, encodes them, stuffs them in the RDP channel, and sends them down to the client, where the client decodes that. That is one improvement that will come to RDSH, just as a function of RDP. So there will be a rev of the client for RDP 7.1 to basically support that encode-decode pipeline. This, in this case, supports this on an ASIC, so the decode side will be able to be supported on chip and also in software, like your MSTSC client. The encode side of it will also be supported 2 forms of hardware, 1 form of software. So actually, I call it software, but really what we're talking about is on the encode side, the protocol encode after it's captured the frames will actually be able to be done on the GPU, if you've got a GPU and VDI, or there will be a chip that hardware OEMs can actually solder onto the motherboard that basically does, I kind of equate it to TCP offload. You buy a NIC with TCP offload into it, and all the TCP work gets offloaded to the card. There will be an ASIC that basically these OEMs can solder on the board that will do the offload for the encode, right? So the other way of doing it, if you don't have a GPU or this ASIC, will be to do it on the CPU, right? So that's the only other place you can really do the encode. So the difference in concept here is RemoteFX really allows full host-side rendering of full 3D content, video, whatever you want, Silverlight, Flash, whatever you like. It can all be done on the host. Today's client with RDSH, whether that's a thin client that you currently buy from HP or whoever, Wise today, in combination with what we formerly called terminal services, does basically RDP client rendering. An example of that is multimedia redirection. And you saw it probably if you came to my session this morning, you saw me doing multimedia redirection. Now what happens in that instance that allows us to play video, and Citrix does exactly the same technique, I should add, through HDX. What actually occurs is as the video goes to render on the host side, the server basically goes, actually, you know what, I can't render that here and send out, this massive stream of video. I'm actually going to be efficient. I'm going to take that apart and send those as primitives through to the client. The RDP client receives those primitives, basically renders them on the client side using the client GPU. That's what we call multimedia redirection. And it's actually pretty efficient on bandwidth. It's probably more efficient on bandwidth doing it that way than actually rendering on the host and sending flattened bitmaps to the client. But in that situation, you can't really do 3D very well. So this is the kind of difference we see today. Now, for those of you who haven't seen this, I've got a bit of a demo for you. So this client that I've got here popped up on my screen. This is the same Windows 7 desktop that we're about to see running RemoteFX. What I've done is I've actually configured it just as a standard Windows 7 VDI VM. So right now I get full aeroglass. You can absolutely do that. Again, you require the local GPU of the client to be able to support this. So there is a value prop for today's thin clients. And I think even some of the thin clients today, you'll start to see some of the price point come down. They'll still have some form of GPU to be able to do this kind of capability. So, obviously this thing can't do that, right? So what do we see when we do this? So I haven't got sound hooked up this time, but we see the same, hopefully again there's no children in the audience. But this is the Call of Duty Black Ops video that I love showing each time because it's nice and consistent and you get the idea, right? So this is full motion video. What's happening here is all those primitives are being sent from this server through the RDP stack, sent through to the client, and we see it rendered on the screen, right? Really clean, full motion HD video. Works great. What happens if I try and do something like 3D content? Well, it's not really going to run that properly because we can't really support that out the other end, especially stuff like Flash. We don't tend to redirect Flash very well, so if I start to pull up a browser, Flash doesn't render in this kind of a model. So what I'm going to do is I'm going to shut this VM down because in the next demo, what we're going to do is we're going to take this VM and, oh, that's nice. I don't have a shutdown button. So let's do it the hard way and go command and run as admin. And yes, shutdown -S -T0. There we go. It's more than one way to skin a cat. So what we're going to do in the next demo is we're going to take that VM and we're going to RemoteFX enable it. So what are my prerequisites here? That VM has to be running SP1, has to be running obviously on Windows Server 2008 R2 SP1 because that's what actually enables this technology, and we have to have a GPU on the server. This machine fulfills all of that. This is my trusty laptop that has a 1 gig Quattro FX video card in it, more than qualifies to running RemoteFX in that scenario. So let's delve a little more into the architecture. So you saw right now multimedia redirection. So what's different and how is this actually working? RemoteFX, contrary to popular belief, actually sits on top of the RDP channel. It uses the RDP virtual channel to actually deliver the graphics capability. All the standard stuff that occurs today in RDP is absolutely still there. In fact, once RemoteFX has finished all of its rendering work and hands off to RDP, RDP then actually produces its own work, basically to get it on the wire, stuff it down to the client, and then the client does its, basically negotiation of the RDP channel and starts decoding. So you get all the multiplexing and framing capability, you get all the compression that you've got from RDP 5 and onwards, all the security negotiations still work, so you get full mutual authentication and encryption end-to-end, so that's all still there, because really we're just being encapsulated within the RDP channel. Everything else doesn't change. The components, though, for you to understand. Now, we always said Hyper-V was extensible, like that we didn't fundamentally have to change the whole architecture in order to support new hardware. And this is actually a great example of that. So from the architecture point of view, we obviously have Hyper-V in the equation here, and RDVH is a function of that. So RDVH is the virtualization host that actually lights up RemoteFX. So what we'll see when we just go through the quick config exercise is you'll see Hyper-V, basically me configuring the parent partition, and you'll see Windows 7 SP1 as a guest OS. RDP stack sits on top of that. It's enhanced and basically revved to version 4.1. What you'll also see is a vGPU driver. What we're doing is we're exposing the GPU from the parent partition in through the VM bus, for those of you who understand what that concept is. Because it's being exposed through the VM bus to the client sees it as a virtual device, loads the appropriate driver for it, hence why you need Service Pack 1. So there's this shared communications memory bus that basically allows all this to occur. So what happens when we render content is it calls the virtual GPU driver. The virtual GPU driver knows how to communicate with the VM bus, sends it down the channel, parent partition receives it, and then through this operation called, I couldn't remember the acronym in Australia, but it's render, capture, and compress. So basically what we do is we render the content that's being asked of us to render from the VM. We then capture frames as required, and we capture the deltas between frames. So if stuff's fast moving, we just capture the changes that are occurring frame to frame. We take that, and then we do some compression on it. So we want to be obviously very, very efficient on the wire. And then we finally hand it all back to the RDP stack. Now, that whole encode operation, which is actually kind of the last function of RCC, also then takes that bit that we need to actually do the encode work, encodes it first, and then, hands off to RDP. So to go into a little bit more detail, if you didn't have enough detail already. So there is a VM bus parent integration, so that obviously has to be there in order for this to work. What you will also see is on the child side, this vGPU driver. Now, what happens on the vGPU driver is it exposes itself as a DirectX 9 capable driver. For those of you who understand video architecture, you're probably also wondering, hang on a second, what about OpenGL? You're saying DirectX, what about OpenGL? NVIDIA drivers support OpenGL. ATI drivers support OpenGL. That virtual GPU driver doesn't support OpenGL. It supports the DirectX 9 extensions. So for those of you who also understand about DirectX 9, that does expose some OpenGL capability, but very, very low level. So like, OpenGL version 1. So if you're using something like high-end CAD, like CATIA, or something that's really OpenGL driven, this won't do it for you. So DirectX absolutely works. Now, I have shown in the past AutoCAD running on this. Unfortunately, my AutoCAD expired because I was just using an eval license on it. But AutoCAD can support DirectX. We don't kind of position AutoCAD as being a primary use case for this because generally some of those CAD drawings are absolutely massive. And in a multi-environment where you've got one GPU potentially serving 5 drafters, you can get contention in the GPUs. So you've got to be a bit careful there. So we've kind of stopped talking about that as much. So, of course, that all communicates through the shared memory comms, back to render, capture, and compress, talks to DirectX 9 APIs to the vendor driver on the vendor side. So on the server side, I've absolutely got the latest NVIDIA driver. That's fine, because what's happening is the render call is actually coming down through a virtual GPU driver, being passed through the VM bus, through the parent integration, through render capture control, finally moves down the stack until it actually gets to the proper vendor driver who knows how to talk to the actual piece of hardware in the box, right? Hopefully that kind of got you all clear. On the encode pipeline, and the reason I want to kind of differentiate this is this can actually work with RDSH. So that whole bit previous was all VDI with RDVH. So even though this says Hyper-V VM child bus integration, RemoteFX vGPU driver, the actual render capture render capture compress part of this can absolutely also work in RDSH. So you see the pipeline's kind of the same, but it's just the encode part of the operation, like the final part of this operation that RDSH can actually go ahead and support. And then, of course, we send out through RDP. So what you actually need in system requirements, you need Windows Server 2008 R2 with Service Pack 1. That will absolutely work with Hyper-V Server, which is the free version, as long as you've got SP1 on there. Standard, Enterprise, and Data Center editions. So full support right across the product range. On the virtual machine side, we limit it to Enterprise with SP1 or Ultimate with SP1. The reason for those is, and the reason the SKU limitations there is, our licensing doesn't support running VDI VMs today with Pro or Home Premium, or whatever those other SKUs are. When you buy a VDA license, you're actually fully licensed to use the Enterprise SKU, or if you've got software assurance today, you're fully licensed for the Enterprise SKU. Or you can go out and buy, FPP copies of Ultimate if you really want to, and whack them in there, and we will absolutely support that. On the client side, Windows 7 with SP1 today will give you the RDP 7.1 extension and devices that actually have the RemoteFX protocol for decode in them. So this is just one example of a device. We're absolutely working with Wise and HP and the other thin client vendors to come out with thin clients, both kind of a thicker kind that you see today, but also the ultra thin kind. So there's some pretty exciting stuff going to be coming from HP pretty shortly on that one. On the server side, we do require SLAT-enabled CPUs. I mentioned it in my session today. Personally, if I'm going out and buying a server today, I wouldn't buy a server without SLAT. It gives you a lot more capabilities than you currently have today with CPUs. For those of you who don't know what SLAT means, Secondary Level Address Translation is what the acronym stands for. Basically what it does is, on a virtualization layer, when I'm trying to move pages of memory around, shadow pages, SLAT-enabled CPUs can do that at a hardware level, where previously the hypervisors had to do the work. What it basically enables us is a lot more scale than we've ever had before. In our testing, we found on a fully loaded box, we had a machine that had same box, SLAT on and off. We basically scaled an extra 35 VMs on the box. So we're starting to make it more of a requirement now as well. You do require something with like at least a PCI Express 16 base motherboard. For those of you going, hang on, what freaking server has a PCI Express 16 motherboard? Honestly, when we started beta testing, we had to hunt high and low as well for one. What we found was the HP DL370 has this. So for those of you who understand what that is, or an ML370, it's basically a 3U rack server. It has a PCI Express 16 card. The only thing it missed for us was we needed some more support from the power rail, because some of the higher end GPUs, like the QuattroFX 5800, which has 4 gig of memory on the card, it's a double width card, but it requires extra power. We had to get just an extra power rail kit. The power supply in the server actually was fully, had enough go to be able to drive it, but we just had to buy an extra power rail kit to make it happen, and we got it going. There is also some options, which we'll talk about in a second, of some external GPU chassis that you can actually plug into the server. So if you've got a server, that you may want to actually get a bit more GPU scale out of, or you don't actually have the physical height in the server to be able to take a full height GPU, but it can actually take, just a PCI card. There are some external solutions that plug out. We'll talk about that in a second. Some of the service SKUs that we're kind of looking at and interested in is the IBM i Dataplex. We think that's a fantastic solution because I believe it actually has GPUs built into it already. The Dell PowerEdge range has some models that absolutely can support GPUs in them. For those of you who see the M610 and kind of go, hang on a second, I've got one of those. I don't think that can support a GPU. It's the X version. So I've got a Dell blade chassis in my office that actually has M610 blades in it, but it needs the M610X because it has some extra room in there to be able to take GPUs. And of course the HP DL370 we've had a lot of success with, and in our tap testing we've been encouraging customers to go ahead and buy that one because that absolutely supports all of the requirements for RemoteFX. And of course, if you want to do a smaller scale thing, or you've got a white box vendor that builds servers for you, you can absolutely work with them and get something appropriately spec'd. In my testing, I've actually built some shuttles, the sort of cube kind of shuttles. I put a 650 watt power supply in there. I've actually got a full ATI V8800 GPU in the box. It's a micro ATX kind of board, so if you just want to play around with it and get a good look at it, that absolutely works, and it all fit in there as well. So on the GPUs that we know and work, like I mentioned, the FirePro V8800 actually works. So both ATI and NVIDIA have great models here. There is one thing though with the ATI cards you have to be aware of. I mentioned before this render capture compress pipeline. Right now the ATI cards do great job of the render, the capture part of it, but the compress part or the encode part specifically that you can do in the GPU, the ATI ones can't right now with the current shipping beta. I believe it's something to do with the driver and the host integration, and both of us have worked on it. From our side, we've done a fix and checked it in for the next beta, and ATI will release some updated drivers for that. NVIDIA can do all of it. We don't have any problems with the NVIDIA stuff at all. Personally, I have the QuatroFX 5800 GPU in some of my servers. Not a cheap card, I have to say. It's about a $3,000 video card and has 4 gig of RAM on it. So it's pretty awesome playing games on. Again, not a scenario for RemoteFX. I have to be super clear because we did see some YouTube videos of some dude installing Halo 2 inside RemoteFX, hooking up the Xbox controller using the new USB redirection feature, and him playing games and it performing flawlessly. Not a primary use case scenario, just want to be clear. Oh, I also say it's for LAN scenarios only for a very good reason. If I'm taking high definition content, basically taking 3D content, rendering it as full HD, stuffing it out on the wire, that's going to require bandwidth, and a lot of it. Nobody's saying, this is going to be super efficient on bandwidth, you're going to run over the WAN. Rich user experience requires rich bandwidth. Laws of physics, people. That's just what it is. That said, that's from us, from Microsoft. That said, Quest and Citrix will absolutely be doing work on RemoteFX to be able to run this over the WAN. Quest already has done some extensions to the RDP stack because they sit on top of RDP. They can take the content already with RDP and WAN accelerate it. And there's a couple of different vendors out there that already can do this, not just Quest. Ericom, I believe, can also do this as well. You probably could do it with some sort of WAN acceleration device as well, like Riverbed or whatever. Some pretty good success there. Anyone who basically can accelerate RDP will probably get a really great experience with RemoteFX as well and accelerate that over the WAN. LAN.
Even in the LAN, I mean, if you have a 100 meg LAN, I'm not sure that will.
LAN. Lots of bandwidth. The more the bandwidth, better it'll go. Because basically, when we actually talk to the... So his question is really what sort of bandwidth, at least 10 megabit and above. That's kind of what we're kind of saying, as well as latency. Latency is also important to consider. The reason is the RCC engine actually talks to the RDP stack throughout the whole operation. So if it sees from the RDP stack that the client's struggling or that there's not quite enough bandwidth because it does a bandwidth sense, it will basically tell the RCC engine to calm down. So it won't capture as many frames. You'll see a bit more compression occurring. So it will do things in combination with the RDP stack to make things a bit more efficient. So it will try and compensate as best it can. Sometimes you might, in a high-moving video, you may see some pixelation because basically that's just a product of the RDP engine saying, hang on, whoa, not so much. right? So I just want to be clear on it. So on terms of the like the RDVH solutions with RemoteFX on top of VDI, you get the full spectrum of capability. On the RDSH side, you get some enhancement simply by virtue of the encode-decode stack. So when you go to your RDP client, all you have to do is just swing it right over to LAN, and you can work with RDSH, and you'll get the full capability of the encode-decode pipeline of RemoteFX working with RemoteFX as well. So let's have a bit more of a look of the server-side demo. Okay, so there's my server. So what we're going to do is we're going to take this VM. He's leaving before the demo. Dude. So we've got the VM here. So this is our VM that's running SP1. So what we're going to do is we're going to take the RemoteFX 3D adapter and we're going to expose it inside the VM. Now, notice what we see here. Maximum number of monitors, maximum resolution. For those of you who understand RDP, you're kind of going, hang on a second, in R2 you extended this to like 16 monitors with full 32-bit color. Why can't RemoteFX do this? Well, bear in mind how that architecture works. A lot of it's occurring client-side render, right? So 16 monitors is fine because the local GPU can deal with that. Full area glass is fine across all of that because RDP, the client side can deal with all of that. In this instance, the server side is dealing with all of the rendering and all the framing and all the capturing. Everything's happening on the server side. It's just being emitted at the client. This requires a little bit more careful planning. We can support up to 4 monitors in this instance, and we can go up to 1920 by 1200. So we can do good res. Bear in mind here the implications. The more monitors you add, the higher resolution you go, the more VRAM you require on your GPU. The more VRAM you require per client on the GPU, the less density you get for your users on the overall solution, right? So this requires a little bit more careful planning. Now, for those of you who go, okay, well, I don't want to buy those really expensive GPUs. How about I stick a few more GPUs in the server? Can you support that? Absolutely. We'll support up to 4 video cards in Hyper-V now. So assuming you can get a box with 4 PCI Express slots, we will absolutely support 4 GPUs and basically load balance across all 4 GPUs in that environment. So basically what we're going to do is we're just going to do 1280 by 1024, and we've got dynamic memory in action here, so we've got a minimum of a gig being started up and just let it go as much as it wants. So we're going to hit OK on that and we're going to start it, and then I'm going to show you basically how I even got to this point. So we'll let that VM start. Now, the first thing you've got to do when you fire up your SP1 box is obviously you put your GPU in. You need to make sure that you've got your video card installed. So, you obviously go into your, I always get lost here. There we go, Device Manager. You go into your display adapters. Great, we see we've got a QuattroFX 2800M video card exposed there. Fantastic, that's the first prerequisite we need in order to get this running. The next thing we need to do is we need to go and install Hyper-V. Now notice RemoteFX is not a child node of Hyper-V, it's just Hyper-V. So you do install Hyper-V, you do your reboot. The next thing you've got to go do is in Remote Desktop Services, notice I've got the virtualization host here as well as RemoteFX. So what you'll see when you go and install the Remote Desktop Virtualization Host role is there's now a child object for RemoteFX. You tick that on. I don't believe that requires a reboot though. In fact, I don't remember it ever doing a reboot there. Once you've got that there, you'll then see all of the UI light up in the Hyper-V Manager. For example, we've started a VM now. That's not good. So we'll go into settings. What you would see now is this become ungrayed. So it says at the bottom there, RemoteFX 3D video adapter. Without all of that stuff configured, that stays grayed. The moment you've got all the stuff configured, it ungrays, you can add it into the VM. On the client side, what we're going to now see as it starts, normally we would actually see the video here. Now, because it's using the older version of RDP, it can omit it because basically this preview pane in Hyper-V console actually is just RDP, really, when you kind of look at it at a base level. In this instance, we now don't see it because we're using RDP 7.1. So now we have to access it through the client. So I'm going to go onto my desktop, And I'm going to go and invoke this particular RDP setting. And the reason I'm doing this is because by default, when you start an RDP session with the MSTSC client, it uses a series of default settings that are generated basically by you, right? So what happens is MSTSC launches, you go over to experience, and you select LAN 10 megabits or higher. What that does is it creates a set of RDP settings that says, these are the experience options I want to negotiate with the target server in order to get this to work. There's one option that's automatically set by default that you don't see. I'm going to go show it to you from here. Right-click, open with Notepad. This is the actual RDP file it creates. This one setting, video playback mode, :I:1 is what it's normally set to. What that means is, if we're going to play back any video now, I want multimedia redirection to occur. Now in this instance, I want to force RemoteFX to be doing everything on the server side, so you get the idea of what you would actually see on this then client. So I've switched this to 0 so that we do all the playback at the host side rather than the client side. Does that kind of make sense? Okay, so I'm going to go and load that up, and I'm going to go open VDI1.rdp, hit connect, put my password in. We're going to make our connect. Now normally what would actually occur after I'd added that adapter is start the VM. So the first time you actually start it after adding the adapter, you'll absolutely see it in the preview screen because RemoteFX actually isn't active at that point. You'll see it in the preview screen, you'll log onto the VM, then you'll see the driver load for RemoteFX, the vGPU driver, and like anything with GPUs at all, you really actually need a restart to make that occur. You'll then bounce that VM, comes back up, then you'll see the video is disconnected, which is basically it implies RemoteFX is working. So right now I'm running in full RemoteFX. So I'm going to go back to Call of Duty Black Ops and going to run that same video all over again. What do we run out of memory? Oh, okay. It's invoking some extra memory. So dynamic memory is going to kick in a second, give us more memory. But you see that video play, and to prove it's not MMR, Windows tab, right? So you see it's absolutely being rendered on the host side. We're seeing flattened bitmaps being sent to the client. It is completely being rendered on the server side. Now let's prove that a little more. I'm going to go over to the server side, and I'm going to fire up Performance Monitor. So here's Performance Monitor. And remember the RCC engine I mentioned just a second ago. Well, there's the processor thread, right? So we see the processor going. I'm going to hit plus here, and I'm going to go into RemoteFX software, and I'm going to pick two counters, capture rate and compression ratio. So you'll see so the render stuff's already occurring. That's occurring on the GPU. The frame capture is the bit where it's actually capturing a number of frames in order to start to stuff out to the channel. Compression is where it's also then sort of taking those and starting to compress them all up. So there's that VM that we saw. Now, if you don't have any RemoteFX VMs, you'll probably wonder, why aren't I seeing any tracing? Now, you've obviously got to be able to select a VM, obviously, for it to trace against. So we're going to hit Add, OK, and I want to just change the colors. I have absolutely no idea why it's always picking the same colors. Hit blue, we'll make that one nice and big. We'll go down to the green one. We'll make that one nice and big. So we can see the two counters we really want to see, which is capture rate and compression. What I'm expecting to see as I do some of these operations is, sure, processor's going to spike. Some of this is computational. But what we're also going to see is the GPU kicking into action. We see RemoteFX starting to capture frames and compress them to stuff out to the RDP channel. Now, it's also a little smart. So what happens if I go play from here, right? If I don't go like this and leave it playing, I see the trace suddenly drop. It's kind of smart like that because it realizes there's nothing worth capturing because the guy's got it minimized, right? So I'm going to now go back, and I see that trace actually occurring. So you see on our capture rate, you see we're actually capturing at about 15 to 20 frames, depending on what it's spiking and actually doing. We're seeing our compression move up and down appropriately according to the bandwidth and the latency it sees. We're not seeing a lot of compression right now because I've got a really fast direct connected segment. Of course it's going to be fast, right? So we don't really need to use a lot of compression here. What that has the effect of doing is enriching our experience. It becomes very, very crisp. So let's go back to the VM. So there's our video. What else does it enable? Okay, let's go back. You saw error glass pop in there as well. I'm going to go pop up just solitaire, just basic old solitaire. But the interesting thing about this solitaire is that operation just there invoked the GPU. Let's go back. And let's go pop, and you see that little spike there where it actually did invoke the GPU to actually do the draw, just for something as simple as that. But basically what this also allows us is full flash support, any type of media. I've played with, unfortunately you don't get Hulu here in NZ, but Hulu is kind of like this online site where you can just go to and watch movies and stuff. For those of you who have friends with VPNs in America, I highly encourage you to have a play with that. But basically you can play full flash video, YouTube, whatever you like, it will play, including Bing Maps 3D, Google Earth, whatever you like. Google Earth in DirectX mode, I have to be clear. But all of that absolutely works. So you get the idea that I get that full user experience that I would expect to see, but to a device like this. All right. For those of you, how many of you are SCVMM customers? Thank you for your business, those 3 of you who put your hand up. SCVMM will gain an update to support RemoteFX as well, so you'll get the full console configuration where you'll be able to go into the UI, select RemoteFX 3D video adapter, the number of monitors, all the resolutions you just saw. So that will be featuring as part of a hotfix for the current shipping version of SCVMM. You won't have to wait for the next version in order to get that. So that's absolutely going to be there. You'll actually get some exposure to actually what's occurring on the GPU itself. So you can see, Quattro FX 580, total memory on that card, the available memory on that card, which will also be important to help you with planning how many VMs am I setting up against this one GPU, help me plan basically for my rollout in my environment. Library support will absolutely be there, along with all the full templating. So as you create the templates and you're adding GPU support into it, that will all absolutely be there in SCVMM. Intelligent placement and VM migration will be supported as well. For those of you who don't understand what that is, I've got a little diagram for that next. But the thing you've got to be cognizant of is if you've got a multi-node cluster with RemoteFX and you've got GPUs in it, the GPUs have to be identical. If you've got multi-GPU also in the Hyper-V server, those GPUs have to be identical as well. It's just basic best practices. You really want to make sure everything's identical across your cluster. It also supports intelligent placement of, okay, I want to, this particular VM requires RemoteFX. If I've got a mixed node cluster where I've got SP1 nodes as well as some RTM nodes, SCVMM is going to know, okay, that's a RemoteFX VM. It cannot go on the shipping, the RTM version. It has to be on an SP1 node. So it knows about that already as well. And it absolutely checks for it. Now, there's this other function called, we haven't kind of come up with a name yet, even though I'm saying dynamic placement. I'm not sure that we actually have the proper name for it yet. But this is basically what it does. For those of you who went in this morning's session, VDI connection comes in to the connection broker. The connection broker goes, your RemoteFX VM's on node 1. You go to connect, but at that particular connect time, that particular VDI node's already at capacity. So basically, SCVMM is talking to the connection broker and going, at start time, can I start this particular VM on that node? SCVMM says, no, you can't. What I'm going to do is I'm going to move it to a node that can support you, starts you appropriately on that node, then tells the connection broker where it is. So SCVMM will absolutely support all of this capability along with full RemoteFX and dynamic memory capability. So there's this other thing called USB redirection. Now, for those of you who know already what we do in RDP, we support high-level redirection. So for basic functions like USB keyboards, smart cards, some headsets, I wouldn't say all, flash drives. That's all supported today in current USB redirection with RDP. However, what we'll get with RemoteFX USB redirection, now bear in mind this is RDVH only, we'll get full support for anything USB. How many of you were in the Citrix session that me and Tony did yesterday? So you probably saw when he loaded the USB device into the session and you saw this pop-up saying, driver being loaded on the client. Now what that was actually doing was it was loading a USB redirection driver to be able to redirect the local USB device into the session. Now when that actually occurs, when we redirect a device into a session, it takes an exclusive lock of that USB device in the session, which means you now can't use it at the local client. Same with Citrix, same with Microsoft. The other thing you have to be aware of in USB device redirection is it requires bandwidth. A lot of these devices we're talking about here, for example, I want to support a CD drive or USB CD drive, whatever, and expose that into the session, should you allow that, of course. That's going to require bandwidth, right? USB is actually pretty heavy on bandwidth. So what do you get in each? So on RemoteFX USB, there's no drivers actually required on the client. What we will actually do in Windows 7 SP1 is we'll actually support some policy to switch that little redirection driver on and off. Citrix does it on the fly. We want to give you a little more control over it. We'll talk about that in just a second. But there's no drivers really required for the actual USB device per se on the client at all. But it does, obviously those drivers are required in the VM. However, with RDP high level, because really it's kind of the client side function, we obviously require drivers on the client side rather than on the session host side. So there's a slight difference there. Also kind of explains why architecturally it's a little bit difficult to do that in session host as well. Right now, what we're saying about RemoteFX USB, because it can be very heavy on bandwidth, we're saying LAN only, whereas with high level, you can support LAN and WAN. So there is a value prop for some of the other devices already working with RDP today. So the things you need to know in order to get this to work. Firstly, you need to enable USB redirection on the clients because that's not enabled by default. So what you'll see in the MSTSC client, there is some options there where you can do plug and play redirection. So if I show you that, it probably makes a little more sense. So if I go fire up MSTSC and I show you local resources, you see more other plug and play devices. Now there is an extra piece that will pop up when you actually have this RemoteFX driver loaded. That requires a reboot to get that driver loaded. So we'll talk about that in a second where you've got to set that in group policy. But once you've done that, you'll see RemoteFX USB devices. Then you'll see the list of other devices you have for USB that you can take exclusive locks in the session for. Go back. So basically we've got to enable redirection on the drivers. We've got to enable RemoteFX on the VM. So it absolutely does require all the RemoteFX vGPU capability. And then off we go. So some new policy that you'll be able to see, you'll be able to configure on the local side as well as obviously in your domain policy because this will be a function of SP1's update for both client and server. It's an ADMX change. You can absolutely put it in your central store for policy if you're using group policy with central store because it's just a basic ADMX file. Next thing we've got to do is we've got to enable it. Once we've done that on the VM, we can then control USB device redirection. So for those of you who were sort of saying, okay, yeah, look, I want to enable this for VDI, but I don't necessarily want the full spectrum of devices being exposed in here. For example, I've got real problems with USB thumb drives. I've got real problems with certain printers. I've got real problems with blah, right? I don't want that to be enabled. You can now block that through the policy on the VM because the VM's now loading it. So you can absolutely control that behavior. So because we're basically creating a USB channel from the client into the VM, you then maybe want to be a little granular on the clients, on the VM side about what you're actually allowing to be installed inside the VM, right? Kind of makes sense. Now we can do that through some of the policies, local group policies or the policies that control USB device on the client, Or for those of you who are using group policy preferences, there's some USB controls there as well. You can absolutely use those on the client as well. Deployment considerations. So we're kind of getting to the end of it. Basically, be aware of the server infrastructure that's required. So you absolutely require SLAT-enabled servers. You require some GPU support if you want to basically expose this. The GPU is probably the most gating factor in RemoteFX because, while you may in VDI say, I'm going to put, 100 machines on a VDI host, in a RemoteFX situation, probably not as much. In fact, nowhere near as much, unless you can get a whole bunch of GPUs actually in the server. So you're probably looking at lower spec servers, potentially, certainly in terms of memory, but your GPU is going to be your real gating factor to density in basically enabling this all to work. In terms of your test scenarios, if you're playing with it, definitely encourage you to play Flash content. YouTube's a good example of some good Flash content. Other videos are pretty good. 3D applications, even better. We'd love to see you testing that kind of stuff. Silverlight content's pretty good to test as well. What you will see is if it's really fast-moving video, like, for example, flocks of birds, tends to cause huge strain on GPU anyway, because the whole screen's basically moving and being changed each time. So there's huge refreshes going on in terms of deltas. That can tend to push it a little, but interesting for you to go and test and see how you're going with that. Again, for those of you who didn't see the session this morning, we've got the Remote Desktop Services Component Architecture poster. How many of you weren't in my session this morning? Okay, so for those of you who didn't see this, there's a new poster. It actually just did get blogged live to the RDS blog, which is blogs.msdn.com/RDS. So there's a link to this particular new poster that's just come out, and it has RemoteFX information in it. What this poster has is session host on one side, virtualization host on the right-hand side, so you see exactly how the two architectures work. It's got a kind of a wrap-up architecture in the middle that shows you how all the dots are connected, and then further breaks out the licensing, connection broker, web access, and gateway components, so you can see exactly how each of these things are working. The one that I like to show lately is the RemoteFX piece, for obvious reasons. If I scroll over to that, the thing that I really wanted them to do in this poster is in RemoteFX show you the differences between session host and virtualization host and exactly what you get in either one in terms of capability. So that's a free download. Absolutely go ahead and get it printed out, whatever you like. And with that, I think I might be not done. Come on. I think I went the wrong way. There we go. I've put in the contents, you can download this from the ComNet. I've put some content in there around USB redirection and getting it enabled, what you need to know. Put some links to the virtualization team blog because they've got some information on there, especially around dynamic memory. The RDS team blog's in here as well, so you can get access to that poster as well as some of our guidance we've got in RemoteFX. I think Brian Madden did a fantastic job in one of his articles explaining RemoteFX in some detail. So if you kind of come out of the session and go, oh, I don't remember that bit, go to brianmadden.com and have a search for RemoteFX on there. He's actually, our engineering team's pretty close to where Brian Madden lives because all the engineering was done for this out of Silicon Valley, and Brian's based in San Francisco. So basically our principal product unit manager literally sat down with Brian, explained the whole thing end to end with him. Brian's actually got a really good grasp of exactly how this works, and I think he did a fantastic article on it. So definitely encourage you to have a read of Brian's blog as well. So this is a leftover from Tech at Australia. I don't know that you guys are going to win a headset or a Windows Phone 7, but thank you very much for coming to my session, and I will see you at the drinks tonight. Thank you so much.